Hi there, welcome to tutorial 7, the first one of the tutorials fully dedicated to turbulence modeling. Okay, for now on, we're not going to go into details regarding geometry generation or meshing. I'm going to give you pre-manufactured cases, and sometimes I'm going to give you also the workbench case where you're going to follow geometry mesh and you will be able to modify everything. In any case, let's talk about this case. This is a classical turbulence modeling case. Okay, this is the turbulent flow past a backward facing step. So what we have here, the flow entering here, you have this step here, then you will have separation, and you have this recirculation region here. Okay, so you're going to have a reattachment point. So in this case, what we're going to do is test different turbulence models. Also, we can play around with the meshes. I'm giving you a few different meshes to see the influence now of the turbulence model as well as the mesh, and I'm going to give you a few guidelines, okay, regarding meshing and post-processing. In any case, here you have a few links, okay, where you can find more information regarding this case. Okay, also you have the original reference, okay, for this experiment. There is plenty of the numerical experimental data. Okay, so what we're going to do, we're going to run and we're going to compare the numerical results against the experimental result for the wall shear stresses here, but you will find data also regarding velocity profiles. So this is what we have. We have the geometry, and this is the initial mesh. This is the first mesh that we're going to run. So as you see, it's a very nice mesh. Okay, so this is a structure type, but you can use also structure, fully triangular, polyhedral, whatever. Okay, it doesn't matter. In this case, see that we have a nice stretching here towards the wall. So this is a wall resolving mesh, but then we're going to play around as well with wall modeling options. Okay. And here we look at the results. So we have the velocity field. See that we're predicting very well here the recirculation area. See here that we have a string surface instance. So here you have recirculation. Here you have also the secondary recirculation, or the vortex here is secondary vortex. So somewhere here you have the reattachment point. Then we can look also as velocity vectors. Again, you can appreciate better here, the recirculation region and the secondary one, and somewhere here you will have the reattachment point. So here we're looking for this point visually, but there are some other techniques, like you can look at the wall shear stresses in the x direction, and when it becomes negative, you know that there is, you have that point. Talking about the mesh quality or mesh resolution, we talked about in the first lectures about the refinement ratio. So here we're plotting this quantity, and remember that you can compute the refinement ratio using integral scales, and the integral scales you compute it using a two-equation model. Okay, so in this case we're using the k epsilon, and this is how you can compute integral scale. You put it here. This quantity can be computed in Fluent. We're going to see that, and this is going to give you this metric. Okay, and the minimum, let's say, for run simulations to get good results, and in the limit on the scale resolve simulation will be 5, ideally 10. So in this case, we're plotting and see that the value that you have here is something about 2. Okay, so, or probably 2.5, a little bit higher, but it's not good enough. So see here that this quantity, this metric is already giving you a good reference, okay, where you need to refine the mesh. And as you can see here, you will realize that it's true what it's telling. Okay, so you see that it's telling you that here you need finer meshes, and see how it's stretched here. Okay, so by the way, you use this criterion in the core of the flow. Towards the wall, you are going to use y plus as we have seen. So see that here you will need a little bit more refinement. Here it is okay, but this is how you can get an estimate how good or how bad is your mesh, okay, by computing these integral scales. Then we are going to plot the shear stresses at the wall. Okay, so you have the experimental, and see here 2 results. So see that here, even if you see that capture a trend, you can do much better, and see that here we have a very good agreement. And the difference here is exactly the same mesh that we saw at the beginning, but here what we have, boundary conditions, 2 different boundary conditions, just to show you the influence, okay, of boundary conditions, and similar behaviors you will have using different initial conditions. Then we do the classical plot, okay, the law of the wall. Okay, remember you can can do this in any case. The only requirement is that, remember, where you do the sample, the flow must be fully developed, okay? And ideally shouldn't be in a recirculation area, otherwise this profile will separate, okay? So see that we have a very good agreement. Even here the mesh is not, see that we're putting the first cell center here about 10. So this is not properly well resolved, so we can do much better closer to the wall. But nevertheless, see that the low region is very well resolved. And that's all, okay? So this is the case that we're going to work it out. In the folders that you can download, you will find here the workbench case, which is this one, okay, here. So see here that you have the geometry and you have different meshes and the Fluent meshes. So see that you have a structure fine mesh, a structure quartz mesh, and a structure fine and quartz mesh, okay? So here you have different meshes, so you can modify this one to get something finer or quartz. It's up to you. And also you will find there I will give you the meshes already converted and the settings, okay? So you get so for those that are not using this version of Fluent, the 2021, you can download the meshes, okay? And then you have the setting files that you can set up the case automatically, okay? It might happen that some actions they are going to give you some problems because this is the setting used in 2021, but it doesn't matter in all versions. Those options that doesn't exist, it won't take that. It will give you a warning. So that's all for this case, for the presentation. So later in successive videos, I'm going to show you how to run this case and do some post-processing. Thank you for your attention. See you next time. Bye.